What's up guys, Engineer Jules here. Welcome back to another video, and today we're going to be doing an Arduino based nightlight circuit with this Iron Man mask. And as we all know, the second most exciting thing about making a circuit is making it look badass. So the first step for this little project is gonna be a nice little paint job. I've been on ghosts as a kid. Now I got house full of kids. Where I keep money is sick. Keep making that money flip. Quick disclaimer, this Iron Man idea I actually got from another YouTuber who actually put the STL files on Thingiverse, so I was able to download those files so I could create my own Iron Man mask. Thank you for that. I will put the link of his YouTube channel on the description below, so you guys can go check out that channel as well and check out what he did with his mask. Keep making that money flip. Way up. Pick it up, pick it up, pick it up, pick it up, that went way up. Bend that mouse to feed, I pray that check flow stay. Try to make it look like there were some battle-worn features on it. However, it just looks like, I don't know, something pooped on it. Not happy with it, but I did put the clear coat on it already, so I guess I'm just gonna have to deal with it for now. However, I'm still pretty excited to see the end product, so let's go check out the components that I'm gonna be putting on this project. It is now the next day. I had to wait for my face shield to dry out before I could keep putting my hands on it. But now that it's fully dry and cured, I'm gonna show you guys all the individual components that I'm gonna be putting on this little face shield. Here's all the components that we're gonna be putting into our Iron Man mask. Let's start off with the power system. We have three 3.7 18650 batteries, and these batteries are gonna provide us with plenty of power. We're also gonna be mounting them to this little battery mount holder thingamajigger, and this is really gonna help us keep the batteries in one place and also allow us to have good connections between the batteries and the components. Now, managing those batteries, I decided to go with this battery management system. It is going to keep your batteries from overcharging, from providing too much current. So maybe there is like a short, it'll keep them from doing that, and a bunch of other things that I can think of, but those are the main ones, main reasons why I got this battery management system. And here we have our buck converter. So this is going to turn our 11.1 volts coming out of our battery power system to 5 volts, which is what we're going to be using for our Arduino. And all you have to do is adjust the voltage coming in through here, and it'll come out on, you know, whatever voltage you want on the other side. Voltage lower than the input voltage. That's why it's called a buck converter. And attached to that buck converter, I'm going to be attaching this little heatsink. Now, I won't need the heatsink for this project, but I just want to attach it anyways, just in case I ever need it, and I just have it on there anyways, and I'll probably lose it anyways. So now it's going to have it on, and I won't need to worry about that. And the lights. So the light for my Iron Man mask are going to be these LEDs right here. Now, the reason I like these LEDs so much is because they are rated for 12 volts. So it means that I don't have to put any resistors on here coming straight from the battery system. It's going to save me so much time having to solder one resistor per LED, or however you want to do it when you install LEDs. Now, all I have to do is super glue this wherever I want, or hot glue this wherever I want, and then route the wires to wherever I want the lights to connect to, and that's all I have to do. I don't have to worry about soldering extra cables to the ends of the LEDs and wrapping the wires just like they did. This is just very convenient. I got this off of Amazon. The main pieces that are going to be controlling the whole project is this little photo resisting sensor. Let me see if I can bring it closer. So the way this light detecting resistor works is whenever there is a lot of light, it becomes very conductive, and whenever there is no light, it becomes very resistive. And of course, we're going to measure the conductivity based on ohms, so resistance. And this we're going to be using to determine when the lights should turn on or off. And of course, driving this whole project is going to be our Arduino Nano. So this right here is the Arduino Nano, and this one I got from Elegoo as well. One of the things I like about this little Arduino Nano is its size, of course, how the name implies. And it's gonna allow me to put them on one of these little DIY PCBs, so I can just make my own little circuit board. I am gonna be trying something rather different with these. Here we have an IR receiver, and combined with this, we should be able to communicate with the Arduino, and depending on what button I press, I can send different signals. We'll see how well I can write this into the code. I'm still not sure how this is gonna work, but it's an idea that I have, and I really want it to work. And lastly, we have a solar cell. This solar cell right here I have made in a different video. I will link to that video down in the description below. But one of the coolest things about this solar cell is that it drives, I think it provides like 13 volts, I can't remember, but it is perfect for the power system that I'm trying to adapt to this project. So a few days have passed since the last time I recorded, but I have gotten some progress done. There's a bit of a wire mess going on in here. So I drew up a schematic that I'm gonna go over in a bit. But let's go look at what I have done so far. So here we have the battery pack that I was talking about. And here is the battery management system. And from here, we go over to the buck converter. So this transforms our 11.1 volts into 5 volts, which is what the Arduino is going to run off of. So we have 5 volts going into the Arduino, and here we have IR sensor, which we're going to use. We're going to use this control right here to communicate with our IR sensor. I'm having issues with the IR sensor right now, and I'm just going to leave it like that for now until I learn more about coding. But I decided to integrate it into the circuit board anyways, just because I know that later on it'll be easy for me to just plug in my USB to the Arduino, my USB cable to the Arduino, and then change the code, make it work the way I want to. So for now, I'm just gonna leave it the way it is. I tried so many hours to try to get that code to work, but no. And I'm not calling it quits. I am just moving on. So this, as I said, is the receiver, IR receiver, and then over here we have the light resisting or light detecting sensor. The way I'm turning on these LED bulbs is through a transistor. So whenever the sensor feels that it's too dark, the Arduino is going to send a signal to the transistor to run the batteries, to turn the batteries on. And those batteries are actually not going to be powered by the Arduino. The batteries are going to be powered by the battery pack itself. So when I show you guys the schematic, it'll make a lot more sense. But let me just show you guys how this beauty works. So what I'm going to do right now is I'm going to turn off all the lights, and you guys will see my beautiful creation turn on automatically. First thing I'm going to do is turn off these lights right here. Now you can see it's a little bit darker already, but bam. Oh, perfection. Now, I don't know how well you guys can see right now, but it's so awesome when something works the way it's supposed to, even though it's not working 100% the way it's supposed to, because I can't get this control to work, and I will do more research on it. I just have to turn on the lights real quick. So I can get the Arduino to read the control's inputs. I just can't figure out how to make the controller control the Arduino as it's running the sequence with the light detecting sensor. You'll see what I'm talking about in a second. And let me just turn it around so you guys can see the actual face piece. Ooh, automatic. Man, That is awesome. Okay, let me go turn on the lights real quick. So as you can see, both times the Iron Man mask reacted to the light around its environment and did what I intended it to do, which brings a lot of joy to my heart. But now let's go look at the schematic and then we'll look at the code so you guys can see a little bit of what I'm talking about. All right, guys, so the first thing we're gonna look at real quick is the schematic that I drew on OneNote of the project I'm just doing. And I'll go over it real quick. Here we have our batteries, 3.7 batteries in series, and here is our BMS, battery management system. It is charged by this solar cell right here, the solar cell panel, which is this one that I have here that I will install on the roof and then route it towards my living room of the house. So we have that solar cell. It's going to charge the batteries. It's actually going to be connected with a diode because I don't want any voltage to go back into the solar cells. It won't really affect it if I don't put that diode, but I just want to play it safe and put that diode. That just keeps the current going only from the solar cells to the batteries and not from the batteries to the solar cells or from anything else to the solar cells. Just one-way current there. Solar cell charges the batteries. The BMS here ensures that the voltage coming in through here charges the batteries, and then it also allows me to power all the other devices. Here we have the buck converter transforming our 11.1 voltage into here, this is actually supposed to be 5 volts, so I'm gonna fix that real quick. 5 volts. So here we have the positive going into the CCN of the Arduino Nano and the minus going into the ground. And as soon as we have those two wires connected, our Arduino is going to be officially powered on. I made sure that the wires I connected here were easily detachable in case I ever needed to power off the Arduino for whatever reason. I can just do it through there. But let's continue on. So here is the light detecting resistor. It is connected to the analog 0 input and also the 5 volts. And at a value of 200 and lower, the Arduino is going to give the transistor a signal to go ahead and turn on the lights, and that is through this right here, a D13. And I had to put a resistor because at full value, which is 5 volts, the lights weren't working properly, and I have to do more research on that, but I was able to get around it through a 220 resistor. So once you put a 220 resistor, that gives the transistor the ability to process the current coming in directly from the BMS battery system and light up the LEDs right here, and then the current will flow from here all the way to ground. And then this little 10K resistor that I have here is a what we call a pull down resistor. And what a pull down resistor does, it just ensures that the voltage at the base of the transistor is always 0 whenever there is no current or voltage going in from that signal pin. However, if you don't have a pull down resistor, there could be a chance that the transistor receives some type of ambient signal, maybe like static in the air or magnetic current, any of those other things that could partially affect a what we call a floating pin, which is a pin that is not 100% grounded. So once you have that pull down resistor, it is always going to be the signal coming from the output pin that controls it and not like a random event. And then lastly, we have our sensor, our IR sensor, which I installed here. And again, this one is just an input, so if you install it and don't use it, it won't matter. But I installed it and I put it into the code. It's just not doing what I want it to do. But let's go look at the code and let me show you guys exactly what I'm talking about here. Here we have the pins declaration. We're just telling the code, hey, this pin is this. So A0 is the sensor pin, 10 is the receiver, 13 is the base of the transistor. For now, I just have this coded out because I don't plan on using it. And over here, I declared some values. So I I just declared that minimum light is going to be at a 200 value, and then max light is going to be at a 600 value. And you'll see why I did that later on down the code. And here is the IR receiver code. I kind of just copied and pasted this from the Elegoo website, which is where I got my receiver from. So majority of this is directly from that website. I did have to edit some of it. For example, pin mode over here. I'm just declaring that pin mode base, which is, you know, the base of the transistor, is going to be an output, and then the pin mode sensor pin, which is where the light detecting resistor is going to be an input, so it's going to read that. So we have those declarations going on there, and then this is just the code from the receiver that just tells the receiver what button from the controller does what, and it prints it out when you press it. But we're not going to use that right now because I added that out of the code. So we're just going to skip that. In a later video, we'll probably get more in depth on this whenever I can figure out how to make it work the way I want it to. But for now, let's go all the way down to over here where it says LDR sequence. And this is the only portion of the code that is actually working besides the setup. And this is pretty much what it's saying. Read the value from the sensor, and then as soon as you read it, I want you to print LDR input is. And once you do that, put the sensor value right after that. If the sensor value is less than minimum light, go ahead and put that signal to the base of the transistor. If, however, the sensor value is greater than max light, then go ahead and turn off the base of that transistor so that way the lights turn off. And as you can see, there's a gap between the 200 mark and the 600 mark where the Arduino is still going to be on. I just did that because I wanted there to be a gap between, you know, when you want the Arduino to turn on and then when you want the Arduino to turn off. That way it's not just like right at 200. For example, if I didn't have that max light value, if somebody turns on the light in the kitchen and now the sensor is reading 205, the mask is going to turn off. With this there is a gray zone where the mask can still operate at the on. However, once it's like bright like maybe daylight, then the mask is going to go ahead and turn off. Down here, I just have the void, the loop just running the LDR sequence. The other stuff I coded out, and I just can't wait till I can figure it out. But for now, I just wanted to show you guys what I have so far because it is exciting how far I've gotten. I've never made a project of this complexity, even though it seems simple, right? A nightlight project, it just seems so simple. Anybody can do a nightlight. All you really need for a nightlight circuit is this right here, a light detecting resistor, some resistors, and LEDs, and an Arduino, or not even an Arduino. Here is a homemade nightlight right here. All you gotta do is put power to this and it works. It works because it's a simple circuit, but I'm just overcomplicating it because I like to learn about things and I get excited about projects that I want to do, and I just want it to be a certain way, and then I find out that what I'm trying to do is not really that easy, and it turns out that I need to do a lot more research than I initially thought. But I'm not gonna keep that from allowing me to make videos. I'm just gonna post them as is, and even though it's a fail, it's still a pass in a way because I got something to work right, and it's an awesome looking mask. If you guys can help me out how to write that, I would so love that. But if you can't, I understand. We are all beginners at one point. I am a beginner when it comes to Arduino code. A little bit more advanced when it comes to actual hardware, but not an expert at everything. So I do apologize if sometimes I sound ignorant. We all have to start somewhere, and I like to share my journey with you guys as I progress. And when I look at where I was when I started a year or two ago, it was night and day from where I am today. Installing the hardware into this Arduino was also another friggin' challenge because it was like trying to play Tetris, and then I had to find adhesives so it can stick together, and then I had to do some wiring management. As you can see right here, there is just shrink tape on these cables right here and right here, and there's still cables everywhere. So I decided that I needed to draw a schematic for you guys so you guys can actually see what all those wires that you're looking at here were. But it's still kind of nice to see all of this put together, and it makes you look kind of cool when you really think about everything that you've done, right? And the other thing is this little white shield right here, the white little barrier. All I did was I took printer paper and put some packing tape on one side, and then I flipped it and then put some packing tape on the other side, and then I just used hot glue and then hot glued the paper to the mask, and that's literally all I did to make it look that way. And then I used I used hot glue to glue the LEDs on. So as you can see, maybe right here, it's just glued by hot glue. And the other glue that I used for this was the 5-minute epoxy, which dries really well, works really well with plastics. And of course, all the electronics were soldered on. And here's what I'm telling you about. I made it easy for me to be able to power off the Arduino. The buck converter is what is powering the Arduino, and all I have to do is connect the wires from the CC plus and ground pins right to that buck converter, and it turns on just like magic, just like that. Eventually, this little solar cell and mask combo, they're gonna be a thing. They're gonna be a thing eventually. So stand by for that. Well, anyways, guys, until next time, hope you guys take care. Happy holidays, Happy New Year, and we'll see you guys later. Peace.